Hello, my name is Z, and I'm going to be explaining the synthesis from how we get from this starting to this end product. So the first thing that I notice is the alkene that we have here is not present in our final molecule, and that proton has been added. And then the second thing I notice is that this alcohol at first glance appears to be untouched. However, we see the addition of a substituent, which tells me we go to an intermediate first and then add the substituent and return it back to the hydroxyl group. So the first step I took was I used H2 and palladium in order to turn the alkene into an alkane. So we broke that carbon-carbon double bond and hydrogenated it. And it doesn't affect anything else because there are no other pi bonds in our structure except for the ones present in the aromatic ring, and H2 and palladium cannot break aromaticity. So what we're going to be doing in the next step is we're going to add PCC in the solution to create a ketone. So PCC turns the secondary alcohol into a ketone and it won't oxidize anywhere else, so it's only selective to this spot. The next thing we're going to do is we're going to add the alkyne that we have here using Grenard's reagent to turn the ketone into a secondary alcohol, because carbon will have a negative charge due to the positive charge on the magnesium, which will abstract the alkyne proton and attack the carbonyl group, creating the hydroxyl group while adding the alkyne. So once that alkyne is attached, we're going to use mercury in order to form an enol, which will then tautomerize into a ketone. So once we have our ketone, we're going to switch hydroxide to a better leaving group in the next step through the use of TMSL and pyridine. And then also, just to mention in this step with the mercury, with the addition of that ketone substituent, we also created stereochemistry here at the hydroxide. So then after we switch hydroxide to a better leaving group with OTMS, next we're going to use a strong oxidizing agent in order to oxidize our ketone and turn it into a carboxylic acid. So once we have formed the carboxylic acid, we're then going to use TBAF in order to form the hydroxide and eliminate our OTMS and get us to our final product over here. So this is the stepwise synthesis, and I believe that this is the best possible synthesis because it follows all the rules.